Alright, welcome back to another video, another AP Pre-Calc video, and today we'll be going over topic 2.5, which is exponential data modeling. A little bit of 1.13 and 1.14 in it where we model like a regression into the TI calculator and kind of solve from there, but there's going to be a little bit more than that, so let's get started. Alright, so here we have sometimes the word problems can be useful, but usually it's not really, to be honest. Like, just look at the numbers. Also here we are missing the equal sign, so actually I'm gonna fix that really quickly. Alright, so I have fixed all of them. For some reason this document took away most of my equal signs and parentheses for some reason. I'm not sure why, but let's get cooking. Alright, so I guess I should read it, but you can read it on your own if you want. The number of worldwide deaths of children under 5 years old due to malaria has been decreasing in recent years. The table above gives the yearly number of deaths in thousands for children under 5 years old due to malaria for several years since 2006. So part A, use the data in the table to create an exponential function. So I'm gonna exponential function. So this is the regression we're going to be using, where y represents the number of deaths in thousands x years since 2006. So we want to plug all of these values into our calculator, so let's do that. So remember, it's math stat and then edit. That's where you edit the table. And now put in all the x values in L1 and all the y values in L2. So I'm going to speed this up. I don't mean no judge, but when you read your teacher's tiring, enough is enough. I'm kind of like a kid. Alright, so I have all the values here. Now what we want to do is click math stat. So this should basically just be a refresher from 1.13, 1.14. Then you move over to calc, then move down to what we're trying to do here, which is y is equal to ab to the power of x. Then you want to go down to an exponential regression, since that's what we're doing, which is 0. So you could just type 0 or arrow down all the way to 0. So we got exponential, and now store regression, and then alpha trace to get y. You can use any y, but any doesn't matter, but usually it depends on what other y's you have used in your calculator's memory. And now calculate and enter. And that should be our equation, so I'm going to write that there. And make sure we're writing into the format that they're told us, a times b to the power of x. So that is what we're trying to find. We're trying to use a table to create an exponential function model for this. Yes, so that should be our answer for part A. So part B, based on the exponential regression model found in part A, approximately how many children under 5 years old are predicted to die from malaria in year 2030? We're trying to find how many die from year 2030. So it starts at 2006 in this data. So 30 minus 6 is 24. So we know, year since 2006 is the x value. This right here is the x value, and this is the y value. So we know that t is equal to the x value. So we can rewrite this as 24 is equal to this equation. Well, you don't have to do this unless you're required to solve it by hand, but just use the calculator to the power of x, and x is equal to 24. So this is basically what we're doing. But in the calculator, you can just plug in using the y that you use. So alpha trace, I used y1, so enter. And then parentheses, the x, which is 24. And then enter. And that should give us our answer, which basically is D24. And that equals to 120.8 or 303. Which is approximately 120 children. I don't know if they actually need our decimals or not, but it's saying approximately. You can't have decimals with children, so it's got to be 10 years whole number probably. Okay, now the next question, we have another one right here. So I'm just going to skip this right here. But just know like what the variables mean. We see M means month here since 2009. And Y, which is V of M, means the daily visitors in millions. So yeah, create an exponential regression using this right here. So I'm going to speed it up, me just plugging it into the table. Alright, so we have our equation here. That's A and that's B, and now I'm going to write that. So V of M. Also, one thing, this right here doesn't have to be X. Usually it's the same variable as this right here, but I'm just putting X for some reason. So for this one, I'm going to put M. But just know that this right here is equal to Y and this is equal to X. So that right there is our equation. Sometimes it might ask for the A value and the B value. This is A and this is B. So part B, based on the model found in part A, how many daily visitors did MySpace have after 20 months? So again, use that alpha trace because we're solving for a Y value when we have a X value, 20 months. So M must equal to 20. We can use the calculator, and yeah. I used Y2 for this equation since it's my second one on this calculator, but it doesn't matter. You can use Y1 and replace your other equation, but know that you are deleting it. And that gives us that number. So daily visitors, that should probably be a whole number too. 7 million. Oh, because it's in millions. So yeah, because it's a million, it should have decimals. About that many million daily visitors. That should be our answer. Oh, actually I wrote it wrong. So it's right there. Wow, funny me. That is a bad outline, but whatever. Alright, so let's answer part C. So let Y equal to A times B to the power of T. So it doesn't say X now, it says to the power of T, so that means that's going to change. Be unequivalent form of the model found in part A. So this form right here, a little messy, but yeah. Where T represents the number of years since January 2009, find the values of A and B. So basically we're changing this original equation up a little bit because we're going to be changing the exponent to represent, or it wants us to write using this form, which has the exponent as T, which represents the number of years since January instead of the number of months. I'm going to rewrite this real quick. So it's T instead, so VT. Well, basically, usually A is going to stay the same because it's kind of like the initial value, I guess. Because we're changing the exponent, the number that is being raised to the exponent will probably change. So basically, looking at back to this original problem, we're changing the exponent, right? But because we have the same exact equation, we're not really changing that equation. We want the exponent value to still equal months since January, but make sure that it has the variable T in it, right? So something with T is equal to M. So given what I just said, basically we're trying to find a way where we can get the number of years turned into the number of months. And how do we do that? Well, we would multiply the number of years times 12, and that's how many we get. So I'm going to rewrite this entire thing, entire same equation, and then the exponent would change. It would be, because T represents the number of years, so it would be T times 12, because this entire thing would equal to the number of months. So if T equals to 2, so 2 years, 2 times 12 is 24, so that's 24 months. So yeah, we want this entire exponent t still equal to months since January up here, because that's our original equation. We're using the same exact thing, same exact a and b. That means that our exponent up there needs to like still equal to that, but part C, we need that variable t in our problem, and t represents the number of years, so number of years changed into months. And that's how you do it. And then what we want to do next, basically want to get this to the power of 12, which we can do. So just ignore that t because we don't know the value, so we can plug that into the calculator. So 0.928 to the power of 12. Basically we're doing that to simplify the equation, so everything else stays the same. And you ignore the variable because you don't know it, so it's completely fine. So 0, oh that's 0.407, so that becomes 8 to the power of t, which now we can do the number of years since we changed this equation up. See, they're not the same now. So hopefully that makes sense a little bit. I was actually confused with this topic at first. And so find the values of a and b. So I'm just gonna, you would write a is equal to, but I'm just gonna simply write arrows since I already wrote it. And then b is equal to this number. So there you go, that should be our answer there. I really hope that did make sense. That's probably one of the harder things to grasp in this topic. So we have another one here. So this already gives us the equation here. You can read this if you want, where m is the number of minutes. Since the video were first posted online, according to the model, how many have seen the video Alien after 2 hours? So we're given hours, but because the equation is using minutes only, we need to change 2 hours into minutes. So 2 times 60 is equal to 120. So just use this entire thing to solve for this. So 391 1 times 0, 7 to the power of 120. That should give us our answer. So just plug that into the calculator. 1391. Also, if you would like to know, 1.07 probably means that it's increasing by 7%. Enter, and that is our answer. So that means around 4,670,683. I guess I'll put the decimal. Saw the video. Now part B, let this equation be equivalent form of the exponential model. This is the original right here. And this is what we're trying to convert into, where S represents the number of seconds. So seconds instead of minutes, since the video was first posted online. So this is like the other equation we just did right here, turning the years into months, except this is turning minutes into seconds, or seconds into months, or seconds into minutes. So again, so this is y, because we're not really told anything else. But I guess you can have it as any variable, so I'll just put y. So again, I'm going to write the same equation, right? So that means that our exponent should be in minutes. And so how do I convert number of seconds into minutes? Well, that would be to divide by 60. So just think about it. 1 second divided by 60 will give us 1 over 60, or 1/6. Or no, that doesn't simplify to 1/6. I don't know why I was thinking about that. It would give us 1/60 of a minute. If you think of 60 seconds divided by 60, that gives us 1 minute. 120 seconds divided by 60, that gives us 2 minutes. So yeah, it's divide, not multiply. Yeah. So that means that it's the exponent of s over 60. So that basically means that this number right here, 1.07, is going to be to the power of 1 over 60. Remember, if there's no coefficient next to the variable, then it's automatically 1. We're doing that, and then we just ignore the variable, keep it up there since we don't know. So we do that into the calculator. 1.07 to the power of 1 divided by 60. You don't have to put the parentheses. I don't know why I'm doing it. And that equals that. So actually, yeah, we're ignoring this right here because it's find a value of b. And so it's 1.001. Pre-calc is usually the first 3 decimal places only. And yeah, that is the value of b. See, when you understand it, it actually is better, hopefully. Now, what is an appropriate domain for the model found in part B? So the domain would just be, this right here is our original one, but we're no longer using minutes, we're using seconds now, so it would just be 180 times 60, and that gives us that number. So rewrite that and make sure with the variable s, and that should be that. Now, number 4, the table above gives the values for function f as selected values of x. Find the equation of exponential regression to model these data. So just plug into the calculator. Don't need to explain that, I guess. So just write this down. The function is f, so f of x. Now, what is the value of f of 5? So we're just plugging in x for 5. Plug in that x for 5 right there. So trace whatever y you use, parentheses 5. And that gives us 60.027. So that was question 4. That was pretty quick. So number 5, problem, yeah. Model is function by f. The number follows is expected to increase by 31.4%. Increase by 31.4%. So we want to add a 1 to whatever decimal percent we get. Each week, that's bolded, at time is equal to 0 days. He had 100 followers. So initially he had 100 followers, so we know that a is going to be 100, f of x, and then multiplied by the percent increase, which is increased by 31.4%. So 31.4% is equal to 0.314, but because it's increasing, we add a 1 to that. If it's decreasing, we would have 1 minus 0.314. It's increased, so it's 1.314 into the power of, so it's telling us each week, right? So this entire exponent, whatever it is, if it's an entire equation in there, but that equation should equal to a week. So we need to include t in it, and t is in days. So how can you convert days to weeks? So you'd have to divide, because if you think about it, 7 days divided by how many days in a week, which is 7. 7 divided by 7 is equal to 1 week. 14 days divided by 7, that equals 2 weeks. That's correct. So it would be t divided by 7. And make sure that, yeah, just really make sure your exponent, really. So they asked us for the expression for it, so that is it. Oh, and this is not x, actually. That is t. That doesn't look like t. And now b, the most popular account on TikTok, is 156 million. 656 million, according to the model found in part A. How many days will it take for Mr. Passwater to have the most followers on TikTok? Use the guess and check method. So it has 156 million followers. And when we look back at this right here, the amount of followers is the y value. Yeah, it's the y value. So f of t, 156 million, replaces x of f of t. So I'm just going to write that. And it is equal to our equation. But we don't know what t is. That's what we're trying to solve for. So I can divide that by 100. So that's what we're trying to solve for t. So basically in the calculator we can graph this, and then we can see the y value is equal to this and whatever the x value is. But that is going to be a little bit tedious. I'm honestly not actually sure how to do that. You can comment below how you can do that. I might post a short about it another time. But for now, yeah. That's why they say use the guess and check method if you don't know how to put it into the calculator. So basically we're just solving for it. You kind of just guess and check. And it would be around 364 days. So t would equal to 364 divided by 7, which is equal to 52. So this to the power of 52. So 6, 7, and 8 you can do on your own. That's just practice, I guess. I can write kind of the answers here. For number 6, you're basically, you have the equation and you're just trying to solve for k. Hint, you'll be square rooting 2.5 by 2.5. Or you're not going to be square rooting, you're going to be 2.5 rooting. And remember, e actually has a value. E is equal to 2.718. Yeah, I will say that it is, whatever you get, it's going to be 418,742 times e to the power of 1.5. And that gives you this number. That should be the answer for that problem. And then for this, VT. Right, that should be your answer there. I'm just writing down answers. Make sure, I probably should have said that you should pause the video and do it. Oh, and I do want to clarify that this has decreased by 17%. So it's, again, 1 minus that one we talked about earlier, and that does give us 0.83. That goes in there. That's the initial value, t, and this is months, so that means that we're correct. And t, let's see, what is t? T is in years. We're changing the equation so that the exponent has m, which is months, and so we're converting months to years. So what would that be? That would be divided by 12. When you think about it, 12 months divided by 12 equals 1, and that is 1 year. 24 divided by 12, 24 months divided by 12 is equal to 2 years. So yep, and this would be, our answer would be k is equal to 0.985. Remember, because it's m divided by 12 now, the exponent would be 1 over 12. For this, you get two equations, and then those two equations, the sums of equation, then you'd solve for a and b. So b is equal to 1.178, and a is equal to 2.885. Yeah, and that is there. So find the values of a and b. And now this is basically kind of just looking. You basically want to add a new column for each. These exponential functions right here, they don't really show a pattern, but we want to fix it so it does show a pattern. Well, these are exponential functions. They're very close to a pattern. We want to fix it so that it does show a clear pattern. So when we look at this, like what's the closest number closest low number that when you like multiply it by a common ratio, then it keep going, like 3 times 3 is equal to 9, 9 times 3 is equal to 27, or 2 times 2 is 4, then 4 times 2, something like that. So we have 0, 2, 8, 26, 80 here. Seems kind of close to multiplying by 3 we have here, because plus 1 here, that gives us 3, plus 1 here, that gives us 9, plus 1 here, that gives us 27. Yeah, that looks like, I don't know any like fast way to do this, but yeah, I could just say just see what it looks near, I guess. So clearly we're adding 1 each time here. So then with that, our equation would be, remember a is equal to the initial, so we use the new initial here, and then the common ratio on the inside, which is times 3 times 3 times 3, so on, to the power of x. And then we need to add something so that it goes back to the original equation. What do we do to get back to the original equation? We would minus 1 because we added 1 here. So let's do the same thing over here. Let's see, what do we do with h of x? It seems this could be 32 because I know 32 divided by 2, divided by 2, divided by 2, divided by 2, and so on. That gives us 2 at the end. So it looks like we can subtract 2, 32, 16, 8. Oh yeah, that looks pretty good. Looks like it's multiplying by 1/2 each time. So h of x is equal to the new initial, which is 32, with the common ratio, the power of x. And what do we do to get back to the original equation? Is plus 2. So that should be our answer. Oh shoot. And so now the last one here. Pause and just do it on your own. But now the answer should be k of x minus 1. Actually, wait, it's plus 1. So it's negative 3, negative 6, negative 12, negative 24, negative 48. Basically, I think the problems will be pretty close. Don't think they'll make it too hard, so that's times 2. So h of x is equal to new initial, common ratio, power of x. What gets back to the original equation? That's minus 1. So yeah, that's 2.5. And that was pretty long. It was pretty long. But hopefully that gets you to understand it better. And I think this helps me too. So yeah, thank you so much for watching. And I hope you're watching the other videos too. Leave a like and subscribe.